These are the frequently asked questions for Algebra 2 for Section 4.5, Day 1, starting with number 12. Solve each equation by factoring. Check your answers, and I rewrote it down here. So they said I'm supposed to solve this by factoring, which tells me I need to go through my normal steps that I would if I was factoring, and I look for a common monomial factor. There isn't anything that I can pull out of x squared, negative 10x, and positive 25. So those three terms don't have a common monomial factor. But as I'm looking at it, I notice, well, this is x squared, and this is 5 squared. So maybe this is one of those perfect square trinomials. So I check by taking 5 times x and multiplying it by 2. And I do get 10x. So that means I can write this as a binomial squared. And when I do that, the x will go in the front, the 5 will go on the back, because remember it was first times first and last times last. And then my sign is determined by the sign between the first and second terms there. And so this needs to be x minus 5 squared. Now in the last section we would have been done because we would have factored and then stopped. But what we have to do now is to say, all right, when is that x minus 5 going to equal 0? And as we add 5 to both sides, we see that it's going to be 5, because 5 minus 5 would give us a 0. We also notice that we only get 1 0 here. And that might bother some people because you're thinking, hey, this was supposed to have 2. Well, if we write this out the long way, it will say x minus 5 times x minus 5 equals 0. And that's the long way that we would normally multiply that because you don't distribute that 2. So you see that 5 occurs as a 0, not just once, but twice. So that's called a repeat 0. So the 5 is the only distinct 0 that we get, but it counts twice. It is a repeat 0. So that's what happens with number 12. The next one on the list of frequently asked questions would be number 14. And we have 3x squared equals 16x plus 12. To solve, we're finding the zeros. It means we need to have a 0 on one side. So the first thing I'm going to do is move everything over to one side, like so. Now the reason that I moved everything over to the left was because I want to keep my a term, ax squared, I want to keep that coefficient positive. And then I'm hoping at this point, hey, can I take a 3 out of all of those? I can't. 3 does not go into 16 evenly. So I start thinking about 1 and 3 and 3 and 1, and that's because 3 is not a perfect square, so I don't need to worry about checking for those patterns. And then in the back, I have a 12 back there. And so I start to think about my factors. I've got negative 1 and positive 12, 1 and negative 12. And again, it's one of those things where when you look at it, you realize, hey, that's not going to help me. It doesn't matter which set I use here. The 12s are not going to help. Could be negative 2 and positive 6, or positive 2 and negative 6. And that should work to give me a negative 18 plus 2. So if that's the grouping that I spend my time on, and I wanted a negative 18 and a positive 2, and again, those hand motions, outside times outside, inside times inside, will help you see you have negative 18 on the outside and then a positive 2 on the inside. So that will give us 3x, 1x, first and first, plus 2, and minus 6. Now, we have just another couple of steps here and we'll be all done. Most of you at this point probably are just looking at that one and already can see 6 minus 6 is going to be 0. If not, set it up, add the 6, and get x equals 6. This one though, you might want to just set it up, and then you'll realize, oh, I'm going to have to subtract 2, and then I'll have to divide by 3. So the other 0 for that one would be at negative 2/3. A little bit more work to finding that one than there is for the 6. But they're both the zeros, so we need to find them both. Then number 17, 2x squared equals 8x. Again, I need a 0 in order to solve this, so I'm going to go ahead and move that 8x over, because zeros are what we're doing when we're solving. We're finding the zeros. And this one I notice, hey, wait a minute, there's a 2 and an x. 2x that can come out of both of those. So at this point, again, most of you are probably saying, yep, that one's going to be at 0. But don't forget about the other x that's out front. So 2x would have to equal 0. That would mean if we divide both sides by 2, one of the zeros is actually at 0. So our zeros here are 0 and 4. And we do get 2 zeros out of that one because it is a quadratic. We have those 2 spots where it is crossing the x-axis. Then, for this first day, number 43 I thought was a good one to go after with you here. It says solve it by factoring, using tables or by graphing, if necessary round your answer to the nearest hundredth. And of course we want to try factoring first. You know, we're hopeful that we can figure out what the answers are without having to use any technology. So I check to see, is there something I can pull out of all of these? There's nothing there. No common monomial factor. Then I check to see if I have perfect squares. Well, the 6 in the front takes care of that right away, and I don't have that. So next thing I need to do is start writing down all those factors of 6 that in first times first position would give me that 6. And then in the back, I don't have to write them both ways because the fact that I switched them up in the front there is going to take care of that for me. So then I start to think, okay, how can I get a 13 out of this mess? You know, what am I going to use here that would get that for me? And just basically think through the different number combinations here that'll make that happen. And you certainly could check through all of them if you want to. But let's see here. We have 9 and 4. Outside times outside. Inside times inside. 3 times 3 is 9. 2 times 2 is 4. And that does add to 13. So it's first, first, last, last. And again, we're not done because we were supposed to solve this. So 3x plus 2 equals 0. Subtract the 2 and divide by 3. Same thing with the other set of parentheses. Subtract the 3 and divide by 2. So our zeros end up at -2/3 and -3/2. Number 45 was another problem I thought people might want to see. 2x squared plus 8x equals 5x plus 20. So again, we have to move everything over and have a 0 on one side. So we'll have 2x squared and subtract the 5x from both sides, plus 3x, subtract the 20 from both sides, minus 20 equals 0. And we go through the list. Common monomial factor? Nope. Perfect squares? Nope. The 2 or the 20, neither one of those is going to be a perfect square. So now those factors of 2, that reversing FOIL would be first times first. And then in the back for the 20, -1 and 20, -2 and 10. Actually, we need to list them both this time since it is negative. So I'm just thinking to myself here, there's going to be absolutely no use for that 1 and 20 there, but I'll list them so you can see those. -2 and 10, 2 and -10, and then -4 and 5, and +4, and -5. And looking for that 3 up there. So again, you know, thinking how is any of this going to be helpful in realizing the 1 and 20, that's not going to help at all. And then combinations with the 10 and the 4, with the 10 and the 2 being 10 and 4, those are not going to be helpful combinations either. But if we can figure out a way to get a combination here for 3 out of these numbers, we would have 8 and 5. So I want a positive 8 out of this, and that would be inside here. So outside times outside gives you -5, inside times inside gives you +8. And negative 5 plus 8 gives us our 3. So it is front, front, oops, pardon me, and last, last. And then again, we're not done because we didn't find the zeros here, but this one will come very quickly. You realize that that one's going to be negative 4. This one, you maybe write that down, and that's about all you need to know. You add 5 and you divide by 2. So that one will give you 5 halves. And let's see, I think I have one more in mind here, number 62. For which quadratic function is negative 3 the constant term? That means it equals c. So negative 3 is the constant term. Well, this one has positive 3, so that's out. This one has 9 sitting right there, so that one's out. So really what we're doing is we're just figuring out last times last, which one of these would give us a negative 3. And here, a positive 1 and a negative 3 would multiply to negative 3. But because it is multiple choice, we should go over here and give this a peek and say negative 3 times negative 3, that's going to give me a positive 9. So here it is, this answer A, just figuring out where that constant term is. And that should be it for the first day.